In this video, we're going to work two more examples of applications of sine and cosine functions. These are pretty creative, I would use a word to come up with. So a circle with radius 3 is mounted with a center 4 off the ground. So we're looking at some kind of like maybe Ferris wheel. The point closest to the ground is labeled P. In the figure, sketch a graph of the height above the ground of point P as the circle is rotated. Then find a function that gives the height in terms of the angle of rotation. So first thing I'm going to do is let's create some kind of graph that may help us, may not. So I know that, and they want it height off the ground. So at time 0, we're following point P. At time 0, my function is going to be 1 foot off the ground. So let's do, I know the highest it's going to get will be 7. So what I'm going to do is... Okay, I'm going to move this axis down because I know it's going to all stay positive because everything stays above the ground. The highest it's going to get is a 7. The lowest it's going to get is a 1. So the midline for this kind of function would be directly in between that, which is going to be, we have 6 in between, so if we add 3, that's going to be at 4. And that makes sense here, right? That's the midline there, and then it goes above and below it. So P is going to start, if I were to graph this, it starts here at 1. And we're going to follow this, and let's just let time be our, instead of time, we'll do the rotations. So I know if it rotates pi over 2, then it goes from 1 foot in the air to 4 feet in the air. So I got 4. And then if it keeps going, when it rotates a complete pi, 180 degrees, then that point's going to be 7 feet above the air. Okay, and then if we go over to the other side, that's 3 pi over 2 rotations. It's going to be, again, at the midline, at 4. We're like rotating right around here. This would be pi over 2. And then if I go all the way, that's pi. And then go all the way, that's a 3 pi over 2. And then the last thing would be 2 pi all the way around. And that gets us back at 1 feet, or 1 foot, rather, off the ground. So our cosine function looks something like this. Yours probably looks a lot better than mine, right? These should be a little smoother. But you get the idea there. They want us to write a cosine function, so y equals my amplitude. Actually, let's write out everything first. So amplitude here, if you look, it goes up and down 3. The period is normal, it's 2 pi. Good, we don't have to mess with that. The vertical shift is that it went up 4. And then the horizontal shift, it didn't move at all. We don't want to mess with that, so none. So if I'm following this function, y equals a, and we can see it's cosine because it doesn't start on the midline. They also told us to use cosine, but we can see it to not use it here because we're not starting on the midline. If it started on the midline, then it would call for sine. So we get a cosine, and then b times x minus c over b plus d. Okay, so we have 3 cosine here. There is no horizontal shift, so b is just 1. Or not b, sorry. The period is 2 pi. So that means the period is not messed with at all. So we're just going to have an x. And then it didn't move left or right, so it's literally just an x. And then we're going to add 4 to move that up to the midline. So 3 is going to cover the amplitude, 4 covers the midline. We didn't move left or right at all. That's why we don't have a B or a C. All right, these are going to be tough. It's hard to see. I had to think for a moment what they wanted to set it up, but that's all they're wanting is a function that represents the height off the ground as this Ferris wheel spins. All right, we got one more. It's based on a spring. Okay, a weight is attached to a spring that is hung from a board. So we have this like block that's hanging from that spring. As the spring oscillates up and down, just moves, position y of the relative to the board ranges from -1, all right, all the way to -7 below the board. So we're going to graph like we did last time, and we know that's going to stay negative because it can't move above the board. The spring can't. So at time equals 0, they said it was at -1. So I know I'm going to need -1, and then the furthest it's going to go out will be -7. Right? We're still going to use time. So we'll use 0 to pi. Let's go all the way to 2 pi and just see what happens. All right, so if I think about this, and then we can find a midline here, because we know it's going to exist since we're dealing with trig. It's going to be right there. That is going to be a -4, like the last problem, right down the middle. It's going to oscillate between those two times. All right, so graphing this then, at time 0, it started at -1, and by the time it got pi, it was here already. So that means it crossed the midline. So any kind of function like this, because it's going to speed up as it extends out and slow down as it reaches the spring going all the way out or all the way in, it slows down. So that's why we have this function like this. As it reaches its ends, it slows down. And then it's going to, if it's at -7 down, it has to go back through. So halfway through, or back to 2 pi, I'm going to have a point right there. And then halfway through is my point. And there is my function that I want to come up with. They told us to find a cosine function, but I can see that a cosine function would be most appropriate here because it starts off the midline. So my a, in this case, is 3. My period is 2 pi. Still took 2 pi to run through it. Vertical shift, we have one, right? It is down 4. And then horizontal shifts, thankfully, because that's the more difficult part, we have none. All right, so now I'm going to fill it in. Y equals a times cosine times b times x minus c over b plus d. All right, we're just going to fill each in part here. So we get y equals. It does start above the midline, so I know, ooh, look at that last problem. Some of you guys may have seen this, and I did not. It starts below the midline. So this in 3 has to be a negative. Sorry for that. I'm glad I caught myself in the video. But the cosine there has to be negative because it started below. This one is going to be positive because it's starting above. Okay, so a then is 3 times cosine. Okay, b, since the period is normal, so this means b is 1. I'm not going to mess with it. There is no shift left or right, so no c or b. So c equals 0. But d equals 4 because we want not plus 4, but minus 4 because I want to move it down. There's my function that represents that spring over t time, and it will bounce back and forth. Again, it comes down to take the situation and draw a picture. I think both of these were pretty difficult until we started looking at where's it actually going to be as the spring's released or as the Ferris wheel moves. Okay, that would be done.